Welcome to today's presentation, Conduit Essentials, Ensuring Reliability in Expanding Data Center Construction, sponsored by Champion Fiberglass. My name is Colleen Beatty, and I'm the Senior Editor here at Electrical Contractor Magazine. On behalf of the magazine and Champion Fiberglass, I want to thank everyone for attending today's presentation. Now, before we get started, I just have a few quick housekeeping items to go over. First, please note that today's presentation is being recorded and we'll be providing you with a link to the recording after the webinar is over. So if you miss anything or if you have to leave early, don't worry. You can come back anytime and watch the recording when it works for you. The audio for today's presentation should be coming through your computer speakers or headphones, but if for some reason it's not, you're having technical difficulties at any point, just reach out to us using the Q&A window on the bottom left of your screen. And of course, we welcome your participation in today's webinar, so please send us your questions through that Q&A module as well. I will highlight that for you now. You can submit them at any time during the presentation using the Q&A window, and we'll have time at the end of the webinar to answer your questions. There's also a quick survey that's going to pop up on your screen at the end of the webinar, and we hope you'll fill that out. Just take a couple of minutes. Or if you'd like to fill it out sooner, just click the icon with the clipboard at the bottom of your screen to open it up. And I'd also like to mention that we've begun offering a certificate of participation. You can claim yours near the end of the webinar in the module on the bottom right of your screen. There'll be a little button that says claim. Now, with all that out of the way, I'd like to welcome back today's speaker, Matt Fredericks with Champion Fiberglass. You may remember Matt from the Champion Fiberglass's webinar last year. Matt brings a decade of industry experience to his role at Champion. He previously worked at Upper Midwest Utility Sales, a manufacturer's representative agency. There, he specialized in selling Champion fiberglass conduit to electrical contractors and the utility market. As the Vice President of Sales and Marketing at Champion Fiberglass, he is responsible for developing high-level relationships within the electric and telecommunications utilities, as well as the contractors that serve them, to increase Champion Fiberglass's market awareness and sales revenues. He also works with the Executive Vice President of Sales and Marketing and Champion Fiberglass manufacturers reps to grow and expand the customer base and market share in North America, especially in the US East and West Coasts and Canada. Welcome, Matt.
Thanks, Colleen. That was a very nice introduction, probably a little too flowery for my background, but I appreciate it. Super excited to be here with you guys today and discuss a little bit of what we're seeing on the data center front in the electrical industry. So what are we going to talk about today? Well, we're going to talk a little bit about what's happening with data centers currently, what's happening in regards with their construction, and then how our contractors are functioning with installation methods. So what's driving demand right now? Well, you guys might be using things like Asana, ChatGPT, Microsoft Copilot. What are all of those? Those are all AI-based programs. AI is a massive driver of data center use right now amongst everything else that we're doing. It's interesting when you look at construction trends right now, that office construction is actually flat. That's a misnomer because of the way the US characterizes office construction. Physical offices that we sit in right now, or in my case, if you're in your home, are dwindling due to data centers. Data centers are actually considered office construction. That's why office construction appears flat, even though office construction, I believe, is down about 20% versus prior to the COVID's building trends. We're also seeing a huge demand in power increase because of data center construction. Data centers actually make up about 4% of US's power consumption currently. And the amount of gigawatts it's going to increase is about 50 over the next 7 or 8 years, which is a considerable amount of power. What does this all amount to? Well, AI isn't going away. Technology isn't going away. We're on a webinar, a web-based webinar right now. And that all leads to more data center construction, more demands on technology, batteries, semiconductors, things of the like. We're also seeing a higher degree of power density, as well as even some new cooling technologies that are being redesigned and re-implemented in data centers as well. So as far as trends specific to data centers, what are we seeing when we're talking about construction? We're seeing things like high density cable coming into play. That's germane to both power, but also to fiber optic cable. And we're seeing extremely high counts of fiber optic cable coming into data centers because there's so much data being pumped in and out of these facilities. Obviously, larger power cable being used as well. To speak personally for Champion, and I'm sure any of other conduit manufacturer would mention this, we're seeing more demand for 8 and 10-inch conduit than we've ever seen really in our company's history right now. And that really has to do with the high demand or high requirements from power for industrial facilities and from data centers. A lot of complex buried installations. Well, what does that mean? There's a lot of power coming into these facilities, a lot of fiber optics coming into these facilities. You've got many different areas of MEP installation, both in the facility, over the tops of the facility, and underground. So you're dealing with limited space. We're seeing a lot more contractors looking at how they can prefabricate these types of facilities or pieces of the facilities and bring it to the job site. That includes huts. Some really large contractors, if you go into their prefabrication facilities, you'll see a sea of huts with control panels in them, switches and the like, that they'll simply drop into the lot where the data center is being built. Naturally, AI is helping out now with our BIM Revit models as well, which is kind of funny. It's circular in nature, if you will. We're using the BIM Revit models assisted by AI to help build more data centers that will help us use AI to use more BIM Revit. We have a shortage of skilled labor right now. That's been going on for a while. So naturally, there's a lot of contractors, many other areas of labor in the United States looking for methods to save time and labor. That manifests itself in technologies that will save time, whether it be on the installation side or we'll say software or programs like an AI piece that will save time and labor. And then finally, with the IIJA or CHIPS Act, things like that, federal funding specifically, we're seeing a lot more focus on BABA, or Build America, Buy America. So that's becoming a pretty large focus for a lot of contractors. They're looking for materials that will meet that type of certification. Not going to belabor the codes here because I don't want to put anybody to sleep, but there are a lot of codes that do govern data center type of facilities that come from both the NEC, from ANSI, from BICSI. There's certain considerations that need to be looked at in regards to how things are grounded, bonded in these facilities. So that's another piece of it. But again, I don't want to belabor that point because I think we have some more interesting things to discuss. So what types of conduit are we seeing in data center construction right now? Well, seeing GRC being used. That's really just in areas of heavy soil compaction. It's more often that you're going to be seeing your regular sort of Schedule 40, Schedule 80, perhaps even HDPE for your short and or potentially long runs for underground distribution. PVC coated rigid steel is used also for some areas of heavy soil compaction and areas with corrosive soil. If you go out to the southwestern United States, you'll notice that most of the contractors there, unlike up here being Minnesota, where I'm sitting right now, we don't have to cold galv or tape our elbows before we put them in the soil. We have beautiful 6 feet of blacktop soil up here that's not corrosive whatsoever. If you go to Utah, New Mexico, Colorado, Arizona, Nevada, places like that, they are threading, cold galving, and then wrapping those elbows with non-corrosive tape. And then naturally, as I am employed by Champion, of course, there's fiberglass in our data centers. And the nice thing about fiberglass conduit is it can be used in areas of heavy soil compaction, corrosive soil, because we're non-metallic. Everyday use for long runs because we have a very low coefficient of friction, and many other places. So talk a little more about design and installation. There's a nice photo of a giant vault there. So what do we need to be thinking about when we're designing a data center or bidding on a data center? Need to be obviously planning ahead as much as possible. I, for one, have a high degree of sympathy for our contractors that we work with, because oftentimes as technology is changing, the scope and scale of data centers are changing, cooling technologies are changing. Sometimes these conduit routes can change pretty rapidly, but as much as we can do ahead of time, we want to plan the conduit routes based on the soil conditions, airflow, what else is in the ground above grade in the building, utilizing those BIM Revit models as much as possible to make sure that we're not in conflict. Because we're using so much AI and technology is improving all the time, we also have to think about what type of conduit sizes we need and perhaps how many blanks we might need for the future. Anybody who's running duct banks, is running duct blanks in the duct banks for future upgrades and capacity upgrades. You also need to have a high degree of coordination between conduit installation and the MEP plumbing systems. That really gets back to being able to use those tools like BIM Revit drawings to make sure you're not in conflict with those systems, because there is a lot of cooling that happens in data centers. So some installation techniques that we can talk about, and perhaps some kit considerations. We'll start at the bottom, talking about things like NECA labor rates. We're talking about labor shortages prior. When we're thinking about areas that we can save time and therefore money on, would be utilizing conduit systems that have a lower labor rate than others, but still meet or exceed the requirements that we need. And NECA, has the manual of labor units that they publish based on time studies that NECA contractors do. They aggregate them into a book. So you can use it for change orders, for job bidding, things of that nature, but it's a very nice publication to use. Other things that we're constantly thinking about in installation too is safety. Trench safety is a really big deal. Unfortunately, you hear at least a couple times a year about maybe somebody not using proper shoring, spending too much time in the trench, a collapse ends up happening, and it's extremely tragic. So, using proper PPE, proper shoring, things of that nature is super important when doing underground work. You want to be using best practices for cable pulling too. It's great if you install the conduit correctly, but if you don't properly install the cable, it may not last that long. You may not have it operational right away. It may just be completely broken, stretched. The insulation, the jacketing might be ruined. And then, of course, you want to use proper techniques when it comes to installing your conduit. That might include bending, cutting, sanding, whatever type of manufacturer recommended practices or NEC required practices are required. So this is a bit of an eye chart. This is available on our website. Want to be clear, when we put this chart together, what we did is we took the data from the NECA manual and then put it all into this table because it's on different pages. So we have it up to date to the current manual. So this is a really great tool to look at when you're considering what types of conduit to use, especially in duct banks where there's potentially hundreds of thousands, sometimes millions of feet of conduit. Really consider, hey, how much time is it going to take me to install a specific type of conduit? And this shows hours to install 100 feet at chest height. That's the parameters that NECA uses for this manual of labor units. Most people know that installing conduit below grade is going to take less time than installing at chest height. But if you use it as a ratio, say it's half the time or something, that ratio still exists. So you can get a good idea of how much time it might take to install one conduit type over another. So that same thought process applies with elbows as well. One area that we see a lot of people look at, let's say a fiberglass elbow over a steel elbow, is in the data center space because you're using, a 4, 5, a 6-inch elbow, sometimes an 8-inch elbow. And a fiberglass elbow is actually going to be about 1/3 of the weight of a PVC elbow and 1/10 of the weight of a steel elbow. But it prevents burn through. It's going to be safer to install because it's a lot lighter. You're preventing burn through, which is really the whole point of using a steel elbow. And it also doesn't have to be taped with non-corrosive tape or cold galvanized. So again, just some things to consider. Like I say, that's available on our website. It's not proprietary information. If you have a NECA manual, you can get the same information from that, but it's not in this easy to read table as we made it into. So what are some challenges that we deal with? And when I say we, what we hear from our contractors in regards to installation or planning a data center. So elbow burn through is one thing that we hear about a lot, and we aim to solve with fiberglass conduit, because if people are using a PVC elbow rather than using a steel or more favorably a fiberglass elbow, oftentimes they deal with burn through. So what is burn through? It generally occurs on usually the last elbow in the conduit run because that's where the most friction is. And that steel or nylon rope, mule tape, what have you, pulling medium, we'll call it, will actually burn through the inside edge of that elbow because the sidewall pressure and the tension gets so great that that PVC elbow can't withstand it. And like I say, it literally saws through that inside edge of the elbow. So what does that mean? Well, I recently had a contractor share with me that when this happens, it's generally between about $9,000 to $12,000 worth of concrete that they have to replace. Well, you say, okay, concrete, I thought this was in dirt. Well, with PVC, a lot of the times they're having to encase it in concrete because it's a little more malleable. It's not as stiff. So if you have a burn through issue, you might actually wreck your cable. That elbow is ruined. You're having to jackhammer up all of that concrete. It's a huge issue. And if you know you might be dealing with burn through, it's highly likely that you're going to be pulling the cable a lot slower than you would perhaps in a medium that's a little more robust. So what other things do we deal with? Well, cable faulting. This is something you don't want to deal with in an underground, well, really, or in any type of situation, because it can be very costly. But when cable faults happen, in conduit below grade, dealing with it can be nothing short of a nightmare. And that's because when a cable faults, it obviously needs to be repaired, replaced, pulled out. But depending upon the conduit type, if a cable faults in PVC conduit, it's actually going to melt that conduit, make kind of a mess on the inside of the conduit. If that happens in a metallic conduit, it's actually going to weld itself to the inside of that conduit, which means that you can't simply pull the conductor out of the conduit system. It won't release because it's affixed to the conduit itself. So what do you have to do then? Well, you have to replace conduit. That's, one of the reasons why somebody might consider putting in several different blank conduits into a duct bank. It takes a lot of time. It takes a lot of money to replace. And when you have downtime at these facilities, it's extremely expensive. I dealt with a contractor that was dealing with the facility out on the West Coast, and the rental, generators that were involved, diesel fuel, different costs that were involved in a cable fault situation. It was pretty astronomical when he shared that with me. So it's something we definitely want to avoid. And one of the ways you can avoid it is through proper pulling practices. But if it happens, we have a solution for you later in the presentation. Temperature range is a huge, huge, huge topic of conversation right now. We get asked about our rate of thermal conductivity all the time because you're dealing with larger conduits now, high density cabling, and you're dealing with, native soil concrete, red dye concrete, different conduit types, spacing requirements. There's so many nuance to temperature ranges. Fortunately, there's quite a few different programs and engineers who do this modeling. It's actually quite complicated. It's a bit of an art, if I may say so. But there are certain conduits that dissipate heat better than others. So, like I say, dense cabling does generate quite a bit of heat. Fiberglass, or RTRC, has a ceiling of 110 C. That's what our heat tolerance is per UL. PVC is going to be 90 C. So we're seeing a larger portion of specifying engineers and contractors seeking out RTRC as a method of ameliorating or mitigating some of these heat challenges. So, just something to keep in mind when you're selecting a conduit type for a data center, that not all conduit types are as good as fiberglass at dissipating heat. All right, so we'll talk a little bit about buried installation, and again, a few things that make it tough. So heavy conduit is one. That's why a lot of people trend towards, your PVC. I will say again, RTRC, you're going to see a third of the weight of Schedule 40, a quarter of the weight of Schedule 80. That makes those 12 to 16 position duct banks, 20 feet long. You can simply take a duct bank and, or a section of a duct bank, and set it into a trench. Whereas PVC, it might be a little too heavy to do it. You want to plan ahead for that. That's why a lot of people are prefabricating duct banks in-house, putting them on flatbeds, trucking them out to a site. You want to have good manufacturer support. That's really important. We pride ourselves at Champion really seeing these jobs through providing as much support on the front end to make sure an installation goes extremely smooth. Additionally, one other thing that I'll mention too is a lot of people talk about fiberglass and say, well, you know, I don't want to have to glue it together. We're already having to glue PVC, and I don't want to use fiberglass because I don't want to have to use glue. Well, fiberglass systems, typically Champion, has a two-part system that you can adhere together without having to use any adhesive that's watertight and concrete tight. So that's an opportunity for folks who don't want to have an extra MSDS on site, or perhaps save some time. There are videos on our website about that. So just a quick material cost comparison that you can glance at here. You can see the difference in cost between GRC PVC coated steel and fiberglass. You're going to see we're about 5 times less in GRC for a 6-inch conduit and about 10 times less than PVC coated steel. What a lot of people miss, especially when comparing RTRC to PVC, is the labor savings. So you want to look at the material cost, and then you want to look at how much labor it's going to take to install fiberglass. Fiberglass is a pretty constant pricing scheme, or price. It's not wavering a ton. Like you see with a steel conduit system or PVC conduit system. And what also stays static is the massive amount of labor savings you get with that type of conduit system as well. So if you jump back and reflect back at the NECO manual of labor units, you can see that cost savings accelerates the larger the conduit size is versus really any other conduit type. So we'll talk about a couple instances that we've had with some data centers. I think we've got 2 or 3, and then we'll get to questions because I'd much rather hear from all of you. So this is a pretty interesting story. This is a data center in the Midwest. It was actually in Iowa. And this was what we called our first PVC conversion. This is when PVC went up, 10 to 12x during COVID. And a lot of people were looking at fiberglass because we were significantly less in cost than PVC. And so we had a contractor and a data center owner reach out to us. We sold the job. And these folks mentioned to us that they could install 15,000 feet of PVC conduit in about 5 working days. That was their pace for their duct bank. They also mentioned to us, that they'd like about a truck of our conduit a week because our truckloads are a little over 15,000 feet. They were particularly interested in our product too because they found out that our RTRC has a much lower coefficient of friction than PVC. Our elbows don't burn through, and it would be a fault resistance material. So that was highly intriguing for the the data center owner, because they're looking at their total cost of ownership. These facilities do need to run for a long time because they're quite expensive. So what ended up happening was we sent them a truckload of conduit. It arrived there on Monday. We received a call on Tuesday saying that they were finished installing the conduit. It was just remarkably fast. Per the NECO manual of labor units, it takes half the time to install our conduit versus PVC at 4-inch, but we're seeing labor savings upwards of 70%. We have a couple other case studies on our website that will readily share that information. I think the real success story here is we worked so well with the project owner and all the contractors on that job that we're seeing consistent business there because we made sure, everything ran smoothly. They got the training that they needed, and it's just a, fabulous project to work on with those folks. So another one that we worked on was in Data Center Alley. Data Center Alley is just outside of Washington, D.C. The the area is just remarkable. An acre of land in that area will go for over $1 million an acre. It's just filled with data centers. But needless to say, this project needed 25 miles of conduit, and they needed it quick. We were able to get it to them in the time frame that they needed, and they were particularly interested in using us because we have had a lower material cost at that time and a shorter lead time than PVC, but we're a third of the weight of what they would normally be using. And again, they knew that they could accomplish easier and longer pulls in our conduit. Fiberglass conduit, if you pull a PVC jacketed cable through fiberglass conduit bare without any cable lubricant, we're at a 0.38 coefficient of friction. If you pull that same PVC jacketed cable through PVC conduit, it's going to have a 0.90 coefficient of friction. So we're almost 70% lower, or 2/3 lower rather, than PVC in our coefficient of friction. So if you pulled straight run to straight run, exactly the same, perfectly horizontal grade, in theory, you could pull 3 times further in fiberglass and have the same tension that you would in a run that's 2/3 less in PVC. So what did this all result in? It resulted in them sharing with us that the installation was easier and it was safer because it resulted in less time in the trench. They were able to prefabricate their duct banks, take them to site, which really helped them meet their installation deadlines. Their labor savings was 60%, and they had a 63% increase in productivity over PVC, which is massive, especially on these jobs that are, you're building a facility that's could be well over $1 billion in cost. So a couple things before we wrap up, just on perhaps a little bit of cost savings, efficiencies, things that we can share from folks that we talk to. So one thing to mention is you do want to balance your cost efficiency with performance and reliability, which I think most people in the electrical industry, especially the contractors we work with, do a really good job of that. Because you do want to make sure that whatever product you're using, you want to make sure it's of a high quality. Perhaps a company has multiple ISO ratings or some really high quality standards, so you get a consistent high quality product all the time. You want to use calculators that are available to you, whether it's that NECA manual labor units. Maybe the manufacturer has some calculators. It could be a pulling calculator from a cable lubricant manufacturer or a cable manufacturer. And then any updated strategies on how you can reduce your labor and material costs without sacrificing quality, which it seems like a lot of contractors talk, and there's a lot of different methods in how to do that, whether it's using different types of tools, AI, just updated versions of common materials, like a newer style conduit system, if you will. So lastly, I'll toot our horn a little bit. When you look at a fiberglass conduit solution, which I would argue increases productivity, is highly cost effective, reduces the overall total cost of ownership, is very easy to use. There's so many different features and benefits as to why you may want to use fiberglass conduit. We talked about cable faulting. We talked about our no burn through elbows that we have. A lot of people come to us specifically because you get a lot of guidance, training, things of that nature. Now you know that per NECA, an independent agency, you're going to see that you're going to have better installation rates per their manual of labor units. If you're using a gasketed conduit system, you actually will need less material because you won't need adhesive. You can literally put it together with a wood block and a mallet. So I know we're going to send out this presentation or make it available to everyone after. So I want to make sure that I don't drone on and on about this, but this whole list of features and benefits will be available to you all. So with that, I will wrap and take some questions.
Thank you so much, Matt. That was such a great presentation. And yes, if you would like a copy of the slides, please feel free to leave a comment in the Q&A letting me know, and we'll try to get them to you. Right, so let's move over to the Q&A module. First question, is there a heavy wall fiberglass equivalent to Schedule 80 PVC?
That's a good question. So we do have 4 different wall thicknesses. We have a standard, a medium, a heavy wall, and an extra heavy wall. When people talk about Schedule 80, there's really two schools of thought. One is, am I using Schedule 80 because I need it per code for areas subject to physical damage? The answer is yes, then. We have what's called our X wall conduit, or extra heavy wall conduit. That, per the NEC under Article 355, which is where RTRC lives, is permissible for areas subject to physical damage. If you're looking for a conduit like Schedule 80 that you need because of areas of, let's say, heavier soil compaction or direct burial use where you're like, I don't really want to use Schedule 40, I want to use something thicker, but you're not using it because of code requirements, we recommend using our heavy wall conduit. Just for reference, standard wall is going to be 0.070 inches thick, medium wall is going to be a 0.096, and a heavy wall is going to be 0.110. So it's going to have about 50% more material on the heavy wall. Our extra heavy wall, which is called out in old engineering specifications as bulletproof, because it will stop a 22 caliber bullet at 20 feet. That's actually a 1/4 of an inch thick. Yes, yeah. We do manufacture in Texas, so there's been well, I'll say perhaps some field testing completed on that. But that is permissible per the code for areas subject to physical damage. So we do see that X-wall conduit being used on under bridge use a lot of the time where they're worried about perhaps like vehicle contact or something like that. So sorry, I just saw another question come up that I was super excited about. They're asking if fiberglass conduit can be bent. Mm-hmm. Yes, that's a question that we get often, because when a lot of people lift it up, it doesn't deflect all that much, even though it does. But I'll get to that in a second. You can bend fiberglass conduit, though. It's the method is almost like if you married bending EMT with PVC. And what I mean by that is our conduit is iron pipe size, so you can bend it around an EMT bending shoe. So it's got the same OD as PVC and other metallic conduits, but we've got a larger ID, so it's better for cable fill. So what you do to bend it is it's RTRC, so reinforced thermosetting resin. So as it cools down, the conduit sets itself. So the way that you bend it is by heating it. So you would put a length into a PVC hot box. You turn it, unless you have a very fancy auto turning one, which I just discovered existed the other day. You get that heated up until it's like about 240, 250 degrees. Then you take it, if it's 2 inches and above, you put it into a one shot bender like you would for, your steel conduit. Fiberglass has a memory. That's because the way that it's wound and manufactured, which means that it also is very impact resistant and has a high degree of compression resistance. So you want to overbend it just like you would with a metallic conduit by a couple degrees. And then remember, thermosetting resin, you cool it down with some water and rags. So after it's cooled down, that elbow will hold its shape. So if it's below 2 inches, honestly, I've seen numerous people bend it with a foot bender. You do have to use heat. You can't just, pull it back like you would with, EMT or something like that. Heat is kind of the secret sauce of it. But yeah, it's bendable. It actually can be forcibly flexed too. I just wanted to mention that, like when we're talking about duct banks, a lot of people use our 20-foot or 20 feet long lengths of conduit. That way they're doing half the amount of joints as tens. If you took a piece of our 4-inch standard wall conduit, which is, I would say, like the bread and butter of a data center, and forcibly flexed it, you can get 26.5 degrees of deflection over 20 feet. And that's honestly mind-blowing to me, because usually when you lift up fiberglass, it seems pretty rigid, but you can actually get a decent amount of deflection to follow that natural curvature that duct banks generally have. So
it's great information. So I just want to remind people, if you want to ask questions, you can use the Q&A module. I believe it's right below my webcam. I'm going to highlight it for you. Here's another question. Is RTRC listed to be embedded in concrete?
Yep, it can be embedded in concrete. It's really interesting about that too is in a lot of these data center applications now, they're concrete encasing conduit. If you remember back to earlier in the presentation where I was talking about heat dissipation, we have numerous engineers and contractors coming to us right now about thermal conductivity and heat dissipation, because if you look in our engineering specs, we dissipate heat faster than PVC does. What does that mean? Well, a lot of times in areas where there's high density duct banks, especially with PVC, contractors are having to use what's called red dye concrete, which is more compact. That allows the heat to dissipate faster. It's a great product. The problem is it's extremely expensive compared to regular concrete slurry or concrete fill. There's a lot of cost to be recouped by using, we'll just say, a different conduit system that might dissipate heat better, and potentially you don't have to use something like red dye concrete. The caveat to all of this, like I said, is heat dissipation is an art form. There are programs out there that model heat dissipation in duct banks. SIME, there's probably 4 or 5 that you can find on the internet right now. They're fairly expensive, but most engineering firms will have them. Otherwise, that there are industry experts that are more equipped to speak about it. But as a general rule, fiberglass versus PVC, fiberglass is going to dissipate heat better than PVC will. But yeah, we have fiberglass in concrete encased applications all the time. It's very common.
Okay. Let's see. How should conduit systems be managed to accommodate future cable expansions or technology changes?
Well, that's where I would say some prior planning is extremely important. You want to make sure that you're going to be running enough blanks to accommodate future upgrades in technology, things of that nature. Um, Using perhaps a conduit system that has better heat dissipation means that it's going to be a tighter installation, less spacing required. So thinking about what types of conduit you're using, and do you have enough empty conduits for the future to really fill those voids. So
Okay. Where a utility requires GRC bends of 22 degrees or greater, what is your recommendation to convince them to use fiberglass?
So we are specified by numerous utilities. We and just fiberglass in general is specified by utilities all the time, and that's really due to the reduction in pulling tension. You've got to figure that utilities are looking for conduit systems and cables that are going to last anywhere from 80 to 100 years. That's why proper pulling practices are super important to them. And one component of that is making sure that you're using a conduit system that's going to be as gentle on the cable as possible. Sometimes the cable that utilities are pulling, especially if you're getting up into, let's say, an 8-inch conduit, if you're doing like an HVDC line, we have numerous utilities doing that with our conduit right now. You really want to use a fiberglass conduit system because it's going to be much easier to pull that cable that's several pounds a foot. And you want to be gentle on that cable so it's not going to have a chance of faulting in the future, treeing, things of that like. So what would I say to them? I'd really go to that coefficient of friction and the lack of burn through would be the two means of convincing them. But if you want to shoot me an email personally after the presentation, be more than happy to provide you with a list of numerous IOUs, co-ops and municipal utilities that specify or sole specify our fiberglass conduit.
I just highlighted Matt's bio module in the corner. His email address should be in there, so it should be very easy to email him if you would like. The next question, does fiberglass pipe expand and contract when above ground and in the elements for building a riser for electric utilities? PVC does this, and PVC also bends bananas from the sun.
So we expand and contract 4 times less than PVC. If you look at our engineering information, I believe we expand and contract 1.83 inches per 100 degrees of temperature change per 100 feet. PVC is going to be about 4 times that. That's why we're commonly used in harsher environments. We have a temperature range of -60 up to +230 degrees, whereas PVC is going to be +40 to +150 for their operating range. So yes, we do expand and contract less. However, we do have a patent pending product right now that we literally just released. It's on our website. It's extremely helpful for a lot of the situations where folks might be taking underground service up to a meter can. So this is for anybody doing electrical service to commercial, industrial, data center, anything like that where it's exposed to the elements. You're trying to bring cabling through a conduit system and it attaches into a meter base. We have a riser now that has an integrated expansion joint in it that allows for 24 inches of expansion and contraction. That's extremely important and helpful for contractors because they don't have to cut custom risers all the time. They can take one part, set it on the truck, go out to the field. But more importantly, going back to total cost of ownership for a data center, a hospital, a homeowner, anything like that, if you live in a cold climate or a warm climate and are experiencing expansion and contraction, I challenge you, if you're out on an evening walk, to look at a lot of these meter cans. Most of them, you will see at least 1 or 2 on your walk where that conduit is ripped clean out of the bottom of the meter box because that PVC doesn't allow for any expansion and contraction. Or perhaps you're in a new build where the soil isn't compacted as well. And when the soil settles, it'll rip out of the bottom of that box. So we have this solution that allows for that expansion and contraction. It has an integrated O-ring in it, so there's no condensation that gets in, and a lock ring that just goes right in the box. So I wanted to make sure to mention that because I feel like that question spoke to that product.
Great. And you were talking about risers. Maybe you could expand a little bit more about the types of support systems that are needed to ensure the stability of conduit in data center projects specifically.
Yeah, yep. So interestingly enough, per the NEC code, RTRC was lumped together with PVC for a long time as far as what our horizontal and vertical support spacing was. We knew that that was, we'll say, unfair or ungermane to our material properties. So we went back, we retested with UL, and now per the NEC code, there's a space in it where there's an asterisk that says additional support span spacing or extended support span spacing is allowed if the manufacturer is tested differently, something to that effect. So we actually have support span spacing due to the fact that we're more rigid than PVC. That's usually 2 to 3 times the length of PVC horizontal and vertically. And depending upon the wall thickness, you go back to that X wall, which is the Schedule 80 or rigid conduit equivalent. We, in some cases, are the same or greater than steel support span spacing. So there's a lot of flexibility in that regard to have greater spacing requirements, therefore less hangers, less strut, things of that nature.
Great. We have time for a couple more questions. Can you speak to how conduit repairs are made with each of the different conduit types?
Sure. So for PVC, you might be using something like a split duct, which either has integrated clips where you can squeeze the conduit together. It more or less connects. Sometimes comes with little H strips and a zip tie. Steel, it's pretty tough to repair steel. I suppose you could attempt to weld it, although I probably would not do that near a cable.
That seems unwise.
Fiberglass, exactly, yeah. Fiberglass, you can use split duct, or you could use, we have a product called a fiberglass repair tape, which is a water-activated, resin-rich tape that looks akin to an ACE bandage, that you can put a piece of split duct over the top or some type of barrier between that and the cabling, of course. Wrap it over the conduit. It is a chemical reaction. It's not UV reacted. So once that water hits it, it starts heating up. It will actually cure and become more or less, it looks like a black cast. It's extremely robust. The adhesion is quite strong as well. So really you're looking at split duct is probably the most common way of repairing conduit. There are also other products that are available on the market that I think are far more user-friendly.
All right. Let's see, I see one more question on here. Have you found prefab conduit solutions or modular installation methods beneficial in reducing project timelines or budgets?
Yeah, very much so. You see so many different methods of accomplishing that. You've got folks that are building huts in their prefabrication facilities, building out those little control rooms, putting them on flatbeds and being able to literally set them right on the foundation or slab of the data centers. You've got folks who are prefabricating duct banks, risers, where they're putting these risers in, support systems made out of strut. There's so many things that our contractors are doing as far as prefabrication goes. It's wild, but I think I think it comes down to the creativity and prowess of the electrical professionals always being such problem solvers. You're seeing BIM and AI play a huge role in that now too, where they can model just wild conduit systems, give it to their prefab shops, and have people, realize this dream in just an amazing way, and, I can't share too much, and the Champion's always very cognizant that prefabrication for really every contractor is their secret sauce. But it's amazing to see how innovative so many different contractors are and what they do in their prefabrication shops. So yeah, I think it's the biggest weapon that our electrical contractors have right now in their back pocket is how they can think their way out of a problem when it comes to how they do prefabrication differently.
All right. Well, I don't see any other questions in the Q&A, so thank you, Matt, so much for that great presentation and that fantastic Q&A. Before we end, I want to remind everyone to claim your certificate of participation. It should be in the bottom right corner of your screen. I'm not sure if it's this way or that way. I might be mirrored, but I highlighted it for you. You can use that for any kind of continuing education credits you may need. And if you missed any part of this webinar, it's okay. You can come back and watch the recording. It'll be available pretty much as soon as we finish up. And you'll be receiving an email in a few hours with the link to that recording as well. So on behalf of Electrical Contractor Magazine and Champion Fiberglass, thank you everyone for attending. And thank you, Matt, for that great presentation again. And don't forget to fill out the brief survey. It's going to pop up on your screen right after I close this out. And like I said, be on the lookout for that email with the recording to watch at your leisure, or send it to your friends if you think that they would benefit from this webinar. So I hope everyone has a great rest of the day, and we hope to see you at a future webinar.
Thank you.